Hey everybody, welcome to the Chapter 7, Section 6 notes over solving exponential and logarithmic equations. In this video, we're going to do exactly that. I'm going to give you an equation. It might be an exponential equation or it might be a logarithmic equation, and you'll use properties of those to solve for a missing variable, okay? So let's get started with example A. Here I have 100 to the power of x equals 1 over 10 to the power of x minus 3. So there's a couple different ways you could approach this, but when I see two numbers like 100 and 1 over 10, they're pretty similar because I know that 10 times 10 is 100. Now if you don't know that, then you might be stumped just looking at this, and you might have to do it another way, and I'll show it to you later. But right now, let's just go back to how are 10 and 100 in common. 10 to the second power is 100 because 10 times 10 is 100. All right, so I'm going to rewrite this 100 to the power of x as 10 to the power of 2, and since that 100 had an x with it before, it'll be 10 to the power of 2x. That's the same thing, okay? So I changed that to a 10. Now, how can I change the 1 over 10 to a 10? What do we know about fractions? We know that negative exponents make fractions. So 10 to the first power is 10, but 10 to the negative first power is 1 over 10. So I'm just going to change this 1 over 10 to a 10 to the negative 1 power. And that was being raised to the power of x minus 3. Okay, so now look what I have here. I have two 10s, okay? The only thing I need to do is I need to get rid of this negative exponent, so what we're going to do is we're going to distribute the x minus 3. So it's going to say 10 to the power of negative x plus 3, because you're multiplying x times negative 1 and negative 3 times negative 1. So it's going to equal 10 to the power of 2x. So once you have the exact same base, then you just take the exponents. So you just take this and this, as long as the base is the exact same. So we got it the exact same, 10 and 10. So I got 2x equals negative x plus 3. Okay, so I can add x to the other side, and I get 3x equals 3. I know that 3 times 1 is 3, so therefore x equals 1 for my final answer. Okay, so that's how we would solve an exponential equation with this approach. If you can get them to become the same base, I feel like that's probably the easiest approach. All right, so let's look at something where you can't get them to be the same base. 2 to the power of x equals 7. I can't write 7 as an exponent, like 2 to any power does not equal 7. So I'm kind of out of luck there. So there's a couple ways you can go about this. All right, so I'm going to show you the longest way first, and I don't think it's all that long, but we're going to convert this to a log, because if you want to undo an exponent, you need to use logs. So I'm going to do log base 2 of 7 equals x. So really, we just need to know what log base 2 of 7 is. So we have nice calculators. The TI Inspires can do log base 2 of 7, but I need to show you how to do this by hand. That's kind of part of my job. So you're going to have to do the change of base formula from the last set of notes. The change of base formula says do log 7, that's log base 10, over log 2. Or you could say ln 7 over ln 2. Personally, I prefer to use ln. I don't have a good reason other than that's kind of what was taught to me, so that's kind of what I just preferred. But also, you could say, hey, I don't have to plug in a base or whatever if I'm typing into the calculator. Just press the ln button. I do 7 over 2. So this is what x will equal. So you just type in ln 7 divided by ln 2, and you're going to get an answer of about 2.807. Okay, so you still need to use the calculator. I know I just said I'm showing you by hand, but this is how you would evaluate it more by hand, like show more work. You wouldn't just leave it like this. You do the change of base formula, and then you do that. So that was the long way, and that way was pretty short. So this is the short way. It's like once you get the hang of it, like I could just tell you, just do ln to both sides. All right, so because of the, what was it called, the power property from the 7.5 notes, it said that if you had an exponent, you could send it to the front. So I'm going to use that power property, and I'm going to write x ln 2 equals ln 7. So I'm doing ln to both sides. So what you do when you do ln to both sides is you just put an ln in front of each term, and if it has an exponent, put the exponent in front. Okay, that's all justified within that power property that I showed you in the 7.5 video. Okay, so when you do that, I can just divide ln 2 to the other side, because ln 2 is some number and ln 7 is some number. So I still get the same answer, but I technically did it in, one fewer step. So, you know, it's to each their own, but that's kind of how it was taught to me. Just do ln to both sides, but I didn't know why. I didn't understand why. So I'm the type of person that I need to understand why. Why am I doing ln to both sides? Look, I do ln to both sides because you turn it into a log, and then you do the change of base formula, and then when you do the change of base formula, you get ln 7 over ln 2, which is exactly what I was telling you to do. So that's why you do that process, okay? So these other examples, I'll spend less time explaining them. But that being said, let's go back to the first example, and I want to show you doing the ln to both sides method with the first example. So let's just say we have this problem and we don't see that I can change the base, and I can change 100 to 10 squared, or I could change 1 over 10 to 10 to the negative 1. So let's say you're stuck on that, but you do know how to, do ln of both sides. If you just take ln of both sides, because of that power property that I showed you in 7.5, you would just take that exponent and put it in front. So this would turn into x ln of 100, and this would turn into x minus 3 ln 1 over 10. And so it looks kind of weird, but if I just divide ln 100 to the other side, and I just kind of ignore the x minus 3 right now, I do ln 1 over 10 divided by ln 100, that gives me negative 0.5. See, this just makes a single number, negative 0.5, and I distribute that to this, I get negative 0.5x plus 1.5. So if I add 0.5 to the other side, I get 1.5x equals 1.5, so x equals 1. So it looks weird, but I'm just saying you can do it, okay? So let's look at a few more examples. Here I have a log problem, but the way you're going to solve a log is by converting it to an exponential equation, just like we had an exponential equation and we converted it to a log. So you're going to take the 2, you take your base, raise it to that power, and it'll equal whatever's in the middle. That's just the pattern we went over in all the other log videos there were. So 2 to the third power equals 5x minus 17. Okay, so 2 to the third power is 8. And then I know I can add 17 to the other side. And 8 plus 17 is 25. So 25 equals 5x. So I'll divide 5 to the other side. And I get x equals 5. So that's just how I would go about it if there was a log problem. Let's do another example. Here I have ln. Remember, ln means log base e. That's the natural log, okay? So by converting it to log base e, you see the base. You clearly know the base. Now, I fully understand it, you don't really have to rewrite it, but you do the pattern we did before. Do e to the fourth power equals 10x minus 9. All right? E to the fourth power is a number. We can type that into our calculator and round it, but I like to do my rounding at the end, so I'm going to keep it as e to the fourth power. And so I just have e to the fourth power plus 9 equals 10x. So I'll divide both sides by 10. Just remember to divide everything by 10. And so in your calculator, you would just type in e to the fourth power plus 9 on top divided by 10. And then you're going to get an answer of about 6.36, okay? So yeah, that's what you would do if I gave you one with a natural log. So in this next example, I'm adding two logs together. And so because of that product property from the 7.5 video, if you're adding two logs together, you can just multiply those outside terms. And if you have a log with no number, you have a log base 10. So what you have here is, when you convert it to an exponential equation, you have 10 to the second power equals 2x times x minus 5. So now I just needed to distribute the 2x and then do 10 to the second power. So doing that, 10 to the second power is 100. I get 2x squared minus 10x. Once you have an x squared, you should get everything to one side because that means you're going to have to factor, okay? And so when I'm looking at this, I see that all my numbers are even, 2, 10, and 100. So if they're all even, they can all divide by at least 2, and 2 is the smallest number on there. So yeah, I'm going to divide everything by 2, so I get x squared minus 5x minus 50 equals 0. So now I just need to figure out what are my factors of negative 50 that add to negative 5. Well, I know that negative 10 times 5 is negative 50, and added together they make negative 5. So this becomes 2 times x minus 10 times x plus 5 equals 0. So if you have x minus 10 and x plus 5 and it's equal to 0, you know your answers are x equals 10 and x equals negative 5. Now here's the thing, x equals negative 5 is not going to work because what do we have? We have a logarithmic problem. You can't take the negative, you can't do a log of a negative number, okay, or 0 for that matter. All right, so therefore x equals 10, whoa, sorry about that, x equals 10 is your only answer. So just make note of that on your paper, that you can't take the log of a negative number or 0. So that's why if you have a negative for your variable, it's probably extraneous. And if it helps, I graphed the original, and then I graphed 2, and you see they only intersect once, and that's at 10, see? So this one's kind of the same as the last example, so I encourage you to pause this video and work it out for yourself, all right? Okay, so here the first thing I did was I wrote them together because they can multiply together, the outsides, because you're adding two logs with the same base. And then I converted it to an exponential, so 6 to the second power equals 6x times x minus 1. This makes 36. This makes 6x squared minus 6x. Get everything to one side. They all have a common factor of 6, so I could divide that out. And that left me with x squared minus x minus 6 equals 0. My factors of negative 6 that add to negative x, or negative 1, I should say, not negative x, negative 1, is negative 3 and 2. So x must equal positive 3 and negative 2. But because of the aforementioned reason, negative 2 is an extraneous solution because you can't take the log of a negative number. Okay? Next section. So here we're going to solve exponential or logarithmic inequalities. It's going to be the same thing as an equal sign for the most part. So in the previous example, I just said to just, like in the first section, I just said to do ln to both sides. So ln 3 is less than 20. And so remember, it's technically ln 3 to the power of x, but you take that exponent and you move it to the front. Okay, so now I just divide by whatever ln 3 is. And it looks like I forgot to write ln by the 20, sorry. What you do to one side, you have to do to the other. So ln both sides. And so all you need to do is type in ln 20 divided by ln 3, okay? And I'm going to get a value that's approximately, here's my approximate symbol, 2.73. So that's not a negative, it's 2.73, sorry. That's the tilde, the approximate sign. So I rounded to about 2.73, all right? But that's really all you had to do. So for B, you have log with no base. So remember, that's log base 10. So you're going to take 10, you're going to convert it to an exponential equation. And so normally we'd write 10 squared equals x, but this is an inequality. So here's the thing. First of all, don't write equals because it's an inequality. But x right here is on the left side, it's less than. So it's on the less than or equal to side. So I'm going to write x is less than or equal to 10 squared. Okay? So just keep x on the side that it originally was on. If it's on the greater than side, make sure it's greater than when you do convert it. If it's on the less than side, make sure it stays on the less hand side. So 10 squared is 100, so x is less than or equal to 100. But since this is a log and you can't take the negative number of a log, you have to add this on every time you have a less than and a log. Notice how it's not underlined, because you have to be greater than 0, because you can't take the log of a negative number or a 0. So just remember that detail, because it would never be 0 is less than or equal to x, because you can't plug in that 0. So it's always strictly less than. Now, if it's greater than, you don't have to add that 0 part on, because that wouldn't really make any sense. Only if it's a less than 1 or a less than or equal to 1. But yeah, that's the final answer, and that's going to wrap up these notes. So thank you for watching. Goodbye, everyone.